random loops, right? Now let's talk about solenoid and ideal solenoid Ideal solenoid is we have a conducting cylinder, and over this conducting cylinder we wrap a wire, closely packed wire. We wrap it around it. Yeah. Once we wrap it around and I send a current through it, I, okay, current through I, can I write flux linked with this solenoid? Flux linked with this solenoid, or for if it has, for example, r radius and n number of turns per unit length, can I write its flux as n phi will be equal to Li? This is the first thing which we learned, right? So can I write its flux in other way also? N phi will be equal to BA, right? BA multiplied by this total length, right? We will multiply by n into L, right? Number of loops, total flux I am calculating. Total flux for one loop.
No, but instead you basically B in terms of solenoid.
Yes, solenoid. Solenoid is, how many loops has solenoid? How many loops does solenoid have? N. What is the area of this solenoid? Is this area? Pi r square. Is this only one loop there? No. How many loops are there? N into L, right? N into L means number of loops. This is number of loops per unit length.
Oh, right? Okay, you just like L is cancelled. Okay.
Yes. Just basically it's A into N. L means total area of these flux, these small loops. Is it clear?
Yeah.
Is it clear? So can I write magnetic field at any point inside this ideal solenoid? Throughout I will take it uniform. What is magnetic field here? Huh? Mu naught? Ni. Mu naught? So can I write mu naught Ni? Mu naught
Ni into pi r square
into let's take A into A into n into L, okay? A into n into L. Is it clear? So further can I write it as mu naught n square A into L. A into L is volume, right? Pi r square L. Is it clear? A into L. N square and multiplied into I. So this is my second equation. We compare them, we get the self-inductance of a
mu naught n square V.
So it is mu naught, yes, n square into pi r square into L, or I can say, to easily remember it, mu naught n square into V. So this is the self-inductance of an ideal solenoid. Self-inductance of ideal solenoid. Okay, tell me one thing. On which factors does it depend? Mu naught, medium, n, number of loops, right? Volume, pi r square L.
It's constant.
Okay, it's constant, and it's also medium dependent, and it's geometry, purely geometry dependent, nothing else. Understood?
Yeah.
Is it clear to you?
Yeah.
100% clear. 100% clear.
2000%.
So if I now add this to a circuit, it will act as a solenoid. So this solenoid, will act as an inductor. It will act as an inductor, pure inductor. What is the time?
9:20. It's in there.
9:18. Okay. Understood this completely? Self-inductance, inductor. Okay. Usually, how we define this inductor, we write this like this. This is an inductor. Having one point A, let's suppose, this point B. If I have to write potential difference across this inductor, there will be potential difference, right? Either growth of current or decay of current. For example, here it is, you remember one thing, how we do it basically. In resistors we write drop of current, IR. Here also we will write drop. Once we write drop, we write like this: minus L di by dt. Minus L di by dt. Then this accordance to question, either the current is increasing or decreasing, we will solve the questions. Okay? Either the current will be increasing or decreasing. Can you write the potential across this inductor like this? See, this is the inductor, this is the point A, this is the point B, this is the L. The current in this is increasing. Once the current is increasing, it will try to oppose the cause. How will it try to oppose the cause? Like this, right? By behaving like a
Battery.
So can I write?
Maybe.
How do I write? Is VA greater than VB? Or VB is greater than VA? I mean potential at A, is it greater than B or less than B?
Greater at A.
Greater at A, because after this there is drop.
There will be
Yeah.
There is drop.
Okay.
Understood? Now how much is the drop? L di by dt. So if VA is greater than VB, can I write VA minus VB is equal to L di by dt?
Yes.
Yeah.
Like this. Is it clear? Is it clear? Is it clear?
Yeah.
Okay, then next part. What if in an inductor I have point A, I have point B. Now what I do is I lower the current. Once I lower the current, it will support the cause. It will support the cause. What is cause? Lowering current. Lowering current will try to increase the current. How will it increase the current? By behaving like a battery, like this. Understood? Now here tell me, is A at higher potential or B at higher potential? This is lower potential, right? This is higher potential. So we are going from lower potential to higher potential, B. So we will write VB minus VA will be equal to L di by dt. But I showed you the trick. Don't think about whether it's drop or whether it's in question. Don't think whether it's a drop or whether it's a gain. Just directly what you do is, if you have inductor, in this direction current is going, okay? This is L minus L di by dt. According to the question, whether it's increasing or decreasing, it will show you.
Yeah.
Is it clear? We will show you. Once you go to question, you will be able to understand. Now let's solve some questions on the basis of this. Let's solve some questions. Okay. The question is, the inductor shown in the figure is how much inductance?
0.5.
0.54 Henry. Okay. And carries a current in the direction as shown. So current is shown in the direction like this. This is not visible clearly.
It is left.
So left, the current is going like this, and inductance L. What we have to do is, in the direction, show that the decrease in a uniform rate, the current is decreasing at a uniform rate. Is increasing or decreasing? How? Minus 0.03 ampere per second. It's decreasing by this rate.
Yeah.
Okay. Find the self-induced EMF and which end of the conductor will be at higher potential and lower potential. Let's see. So current is coming like this, right? Current is coming like this. Is it increasing current or decreasing current?
This is
Decreasing current or increasing current?
Decreasing.
Decrease. The rate of current with respect to time is decreasing. So current is decreasing. Once the current is decreasing, it will try to increase the current by acting like a battery.
lower to higher potential.
Lower to higher potential. Tell me which is at higher potential and which is at lower potential.
A.
So this question is gone. Finish. VA is at higher potential.
But how do
and
we
VB is at,
explain that VA is at higher?
because we are going from lower potential to higher potential. See, it's supporting the
How do we
cause.
write that?
I will show you how we'll write that. Okay. I will show you how we'll write that. Find the self-induced EMF. Is self-induced EMF easy to write?
Yes.
How? Write self-induced EMF. E is equal to minus L d phi by, sorry, di by dt. So minus L, what is L? 0.54
That's also correct.
and di minus 0.03. How much is the EMF induced?
164.
164. Next question I will show you.
162.
Whatever.
162.
See how we will do it. I will show you in this question. Find VA minus VB. Find VA minus VB. We have to find VA minus VB. We will do nothing. In the direction of current. If we are going in the direction of current, this is at, let's suppose VA potential. This is at VA potential. If we go in this direction, there will be minus IR. Right? Again, here I told you, in the direction of current, we will write minus L di by dt. Okay? So, this is how we will write. VA minus IR minus L di by dt is equal to
EMF.
Oh my day. Kirchhoff law.
VA minus VB is equals to.
So VA minus VB will be equal to IR plus L di by
DI by dt.
Oh my god.
what is I? What is
4
I?
amps.
4
4 ampere.
ampere. What is resistance? 5.
5.
So it is 20, right? 20 plus L. What is L?
200.
0.5. 0.5 into
No, 200.
200.
And it's 2.
2 into 0.5, right? How much?
1.
1. So how many volts we got?
21.
21 volts. 21 volts. See, think about this way now. Is current increasing or decreasing? Increasing. Once current is increasing, this will not accept this increase in current. It will try to decrease the current. So it will act like this. And EMF of this will be 20 volt. So how much? 1 volt. Right? 1 volt. Now think about this. There is continuously a drop in potential, right?
Yes.
Here also resistance, drop in potential, drop in potential. Is VA at higher potential, VB at higher potential?
VA.
VA is higher, VA minus VB we wrote directly, IR plus LDI.
Wonderful.
Clear?
Yes.
Wonderful?
Yeah.
Okay. Then you do try this question. If it's wonderful, then you try this question. Same thing you have to do, step by step, same thing. Today we finished a lot of portion.
Yes. We made good progress today.
Yeah.
Someday we make good progress and good energy.
So have a coffee.
Red Bull.
We might finish with portion.
Right, VA, drop, don't think, minus LDI by dt.
Yes.
According to question, if it's increasing or decreasing.
Yeah.
You get the answer, then think about the logic. What's basically happening? Drop, here also it will be maybe not drop, decreasing, correct, you try to increase. It's not a drop there. And here it will be drop. Drop, drop,
It's
and
increase.
increase.
Drop, increase.
2 drops and 1 increase.
Yes.
Same also learning with you. Remember that. While teaching you, I can analyze it better. After this, we will do JEE means question like cut, finish. Cut like this.
Yeah.
Finish. So inductor basically, what is it trying to do? It's acting like a battery. How it's acting like a battery? It's opposing the current.
Will either discharge the.
It's something which stores magnetic energy, magnetic field in the form of it. You can write in your own words. Yes.
So 35.
This is one of the toughest part in
35?
Hmm?
35.
I don't know. This is one of the toughest part in terms of concept. EMI. Let's do it. Did you do it? You.
Yagna Sai Gunda.
Jagna, why? Did you do it?
I'm doing.
Okay. Try.
Catch up, guys.
This is at VA potential,
Yes.
right?
Yeah.
Going in the direction of current, there is a drop.
Mm.
That is minus IR.
Yes.
Without thinking, in the direction of current, minus L di by dt. What about this? What about this?
Minus E.
Because drop, higher potential to lower potential value, minus E. Right? But once we put di by dt here, negative,
It become
it
positive.
will become positive. That it means it will be like this. It will behave like this. Okay?
Yeah.
Okay, got it?
Yeah.
Yeah.
So we will write VA minus
35.
IR minus L di by dt minus E will be equal to VB. So VA minus VB will be equal to IR plus L di by dt plus E. So I how much? I
2 amp.
2 amp. 2 amp multiplied by 10. How much?
20.
20 plus L di by dt. L 5. 5 into 5. 5 into
Minus
minus. How much?
Minus 5.
Minus 5.
Yes.
Plus E.
20.
Plus
20.
20. So 35.
Yeah. Volt.
The answer.
Yes.
Khatam.
Very
Khatam.
nice.
Easy.
Very, very nice.
Khatam. This is JEE Mains 2023.
Oh my god.
Mains or?
Means. Wow. Nothing.
So this is too easy, sir.
Yeah.
Give me
Uda.
Okay, one second. This is similar type. Same question. Oh.
Uda diya?
Yes, 30.
30.
30.
So here how much drop?
24.
24 drop, huh?
Yeah.
Here how much drop?
Minus.
Either drop or plus.
This is gain.
This is gain, right? L, how much L?
Yeah.
Plus 6.
6 into minus L di by dt, minus L di by dt, minus L, what's L? 6 into minus 1, how much? Plus 6. Right?
Yeah.
Because we put, what about this? Minus 12.
Minus 12.
Minus
So VA minus VB
Is
will
equal
be
to
equal to 24 minus 6 plus 12, right?
Yes.
That is
Plus 6.
how much?
30.
30.
Oh my god.
31.
J means kata. Kata J means. Huh? Try these for your homework.
Okay, sir. Thank you.
Nothing. Okay.
So this one's Spotify.
Huh?
First one's Spotify.
You have to do it on a page. Because this is.
I heard Spotify.
I will get.
Yeah.
I will get fine if you don't do it.
Okay.
Yes, really.
Sir, we don't want
Today
to
they-
do that.
So we'll make you perfect.
This is good question, I guess.
Make you fight.
No, same question, huh?
Yeah,
No,
same.
same.
Sir, too easy for us, sir. Next topic.
Yeah.
Next topic.
Energy stored in a conductor.
We'll write notes
Inductor.
and do.
How do we write energy stored in an inductor now?
Oh.
Oh yes. Tell me.
Compared to something.
Huh?
S.
Li
half
square.
Li square. Li square.
Half Li
Half Li square. I almost forgot.
Half Li
Square.
square.
But how?
So how? we know power
is
equal to I
is equal
or
to,
I square R
yes,
VI. Or
so
V
power
square
will be
R.
dw divided by dt, right? Or we can write ei.
Yeah.
So can I write this work done, whatever electrical work done is, there it's stored in the form of magnetic field, right? So work done is basically stored in the form of the magnetic potential, right? For magnetic fields. Is it clear? So can I write this work done, small work done will be power into dt, right? So once I integrate it, can I write power in E into I with respect to dt? Is it clear? So can I write is E as L di by dt, L di by dt into I into dt. Is it clear? So dt gone. I will write L I with respect to dt from 0 to I. Okay, from 0 to I.
So not D. I into D.
Sorry, di is this.
Yeah.
Okay, it will be half
I square.
Li square, half Li square, half Li square. This is for any inductor. This is for any inductor. Once we place the value of L, for a solenoid, what is the value of L? Inductance mu naught. Remember this, N square. Remember this directly. N square into mu naught N square into V, right?
Yeah.
Yes, volume.
Okay. What is volume?
Square.
Pi R square into L. Okay. So if we place it here, how much we will get potential? We will get half L mu naught and N square into V, right? Mu naught N square into V into I square. Is it clear?
Yes, yes.
Finally, if I square this and divide mu naught, no issues, right?
Yes, no issue.
No issues. So finally we can write mu and I as B. Magnetic field at a point inside mu naught and I. Is it clear?
E square.
So we will write half B square V divided by mu naught.
Yeah.
This is potential stored in full inductor. If we want to find potential stored in per unit volume, we will write U is equal to U by V, right? That will be half
B square by mu naught.
B square by mu naught.
Oh my.
So this will be my potential energy stored.
All the secrets getting revealed again.
All the secrets getting- Is it clear? No issues?
No issues.
So should we move further?
Yes, mutual inductance.
Mutual inductance? Okay, let's see how much we can. Can you try this question now?
Okay.
Calculate inductance of an air-core solenoid. L we have to find. Containing 300 turns. Containing 300
Capital N.
turns. Yes, capital N. 300 turns. If length of solenoid is 25 centimeters and its cross-sectional area is 4 centimeter square. Okay? Try it.
Very easy, sir. Don't worry.
How?
U naught.
L is equal to mu naught N square into pi R square into L. Pi R square is A directly, A into L, right? Clear? But N. But this is N. This is N. Can I write N is equal to N into L?
Sir, what's value of mu naught?
Huh?
Value of mu naught.
1 by
4 by 10 to the minus 7.
Yes, yes.
9, right? 9 into 10 raised to 9. 10.
10 is minus 7.
So 9 into 10 raised to minus.
No.
No, the whole thing.
4 pi into 10 is per minus 7. So mu naught by 4 pi, right? 4 pi into.
Yeah, but if you take that 4 pi, 1 by 4 pi gives us what?
What 1 by 4 pi?
1 by 4 pi is 9, right?
4. See, mu naught by 4 pi is 10 is per minus 7. So mu naught is 4 pi into 10 is per minus 7. Got it? mu naught by 4 pi, mu naught
Okay,
by
okay.
4 pi is 10 to the power minus 7. So mu naught is 4 pi 10 to the power minus 7. But the problem here is we have n, so we can write this n square divided by L square.
Sir,
Into
144
A
by
into
25.
L. This L and L gets cancelled. We have n value. We put n value. We get L. Once we get L, calculate the self-inductance of solenoid.
144 by 25 microhenry.
Calculate the self-inductance of solenoid if the current through this decreasing at the self-induced EMF you will find. Can you find self-induced
Yes,
EMF?
I can. Nothing can stop me.
Nothing can stop you now, huh? Oh. Remember this, small n means number of turns per unit length.
Sir, ampere per second centimeter is in the same SI unit?
What?
Ampere and centimeter, same SI unit.
No, how?
We have to